Okay, so here I will show you how to do multiplication. Two matrices can only be multiplied together if you've got the number of rows of the second one is the same as the number of columns in the first one. Okay, so one way of doing it, especially initially till you get used to it, is labeling the rows of your first matrix as A, B, and C, because that's the first thing you're going to look at it, how big it is, and then labeling the columns of the second matrix as 1 and 2. And then you're going to create a matrix that is the result of matching up the row A with column 1. So you create like an entry 1A here. And then you're going to match row B with column 1. So it's going to be 1B here. And you're going to have 1C. So notice A's are going to be in rows and 1 are in columns. And then the column 2 with row A, so it's 2A. And then you get 2 with row B, so 2B. And 2 with row C, so 2C. So you're going to end up with a 3 by 2 matrix. The 3, because there was 3 rows in the first one, and 2, because there were 2 columns in the second one. Let's see how you multiply now. Okay, so very carefully, you've realized, let me just color code it, that you're going to take your entry from row A and match it up with column 1. How do you do it? Well, you're going to multiply the corresponding numbers together. So the first numbers will get multiplied, so 1 gets times by 5, and you're going to multiply the second numbers together, 2 times 0, and you're going to add the two results. Okay, this is your entry 1A. Okay, I'll just do the little separating lines. The second entry is going to be 1B, so you're going to take the second row and match it with the first column. So you're going to get minus 1 times 5, add 0 times 0. Then you're going to take the third row and match it up with the first column. So you're going to get 4 times 5, add minus 2 times 0. Moving on to the entry 2A, you're going to match these two together. So the second column with row A. Let's have a look what we're going to get. Minus 1 times, so 1 times minus 1 if you prefer, and then add 2 times 8. The second, so B's with 2's will be matched together, so it's minus 1 times minus 1, and then 0 times 8. And then you're going to match C's with 2's, so it's 4 times minus 1, add minus 2 times 8. Just work them out. So you're going to get 5 from the top answer, minus 5, and 20. These will be just zeros here. And here you're going to get minus 1 plus 16, so it's 15. 1, because that's 0, minus 5 and minus 4 and minus 16 is minus 20. There you go. Okay, so we'll go through another example from the textbook in a minute. Okay, so this time we're going to go through example 5, 6, 7, 8, and it's all about multiplication. So far we've done adding, subtracting, multiplying by a scalar, and now we're going to look at how to multiply two matrices together. Now, a curious thing here is that you can multiply matrices that are not exactly the same in size, but there is a certain condition. So that condition is you can only do, let me just write AB first here, 1, 3, minus 2, 4, multiplied by minus 3, 2. And then here we'll put minus 3, 2, BA, multiplied by 1, 3, minus 2, 4. Okay, so the only way you can carry out multiplication if the number of columns in the first matrix matches the numbers of rows in the second matrix. Okay, I kind of imagine pushing the second matrix up and making it flop on top of the first matrix, so the blue bits will match up. If you try to do it over here, if you lift the second matrix up, will you get 2 rows here matching with 1 column over here? No. Okay, so this one is not correct. Now really what it is, I need to make sure that I've got the number of columns in the first matrix being equal to the number of rows in the second matrix. So here actually we can answer part B straight away. Why can't BA be found? You could say the number of columns of B is not the same as number of rows of A. Okay, that will do. Okay, so how do we carry out multiplication? So I'm going to do this. I'll just put the answers here because we probably won't have enough room to do it properly. So let's just rewrite that multiplication. So we've had 1, 3, minus 2, 4. Now what you may do for the first example, imagine shifting this way. I told you I could lift it up and topple it over. You actually might prefer to actually draw it, the multiplication out like this. So writing the second matrix higher up. Okay, we're going to multiply it together. Okay, so you're going to match. So what I was saying to you, you're going to match the first row with that column. Okay, and what you're going to do, you're going to multiply the first elements together. So you're going to do 1 times minus 3, and you're going to multiply the second entries together, minus 2 times 2, and you're going to add the results. Okay, for the second one, you do exactly the same. So remember, you're stacking these with those 2 numbers. So you're going to multiply the first entries together and the second entries together. Okay, and this is going to be your answer. So what am I going to get? Minus 3 minus 4, so minus 7, minus 9 plus 8, which is 1. Okay, so if you choose not to lift it up, you need to be very careful. Okay, it's this one needs to match up with these. So that's as your first entry. So it's minus 3 times 1, so it's minus 3, and then minus 2 times 2, which is minus 4. Okay, and then the second one you're going to get by matching this one here with this one here. You're going to get minus 9, and then 4 times 2 plus 8. So the answer is minus 7 and 1. Okay, moving on to example 6. Now we've got 2 matrices. They are 2 by 2 square matrices. We can actually carry out both multiplications, AB and BA, because they both have the same number of columns and rows. So let's do this one. I'll do this one the same way as the first example. So I'm going to write my AB, my A first, minus 1, 2, 0, 3. And I'm going to write matrix B a bit higher. So it's 4, 0, 1, minus 2. Okay, and we're going to carry out the multiplying. So over here, what we have got, remember, stacking chimneys, this second one topples over, so this column matches with this row. Okay, so that creates the top left entry. So you're going to do minus 1 times 4 and then 0 times 0. Now then you're going to match this column with the second row. So you're going to get 4 times 2, or 2 times 4, and then 3 times 0. That creates the first 2 entries. Now we're moving on to the next one. So over here we are going to move on to the second column and match it up with the first row. So you're going to get 1 minus 1 times 1 plus 0 times minus 2, and then you're going to match this column with the second row, so the red column. So you're going to get 2 times 1 add 3 times minus 2. Okay, so what is the answer? So AB is going to be minus 4, 8 plus 0, so it's 8, minus 1 plus 0, so it's minus 1, and 2 minus 6, minus 4. Let's have a look at BA. So BA, so I'll do it without writing it so high. So it's 4, 0, 1 minus 2, minus 1, 2, 0, 3. Okay, so we're going to match these two together. Let's do them quicker. So the first top entry is going to be 4 times minus 1, so it's minus 4, plus 1 times 2, so it's 2. And the next one, you're going to match that column with those bottom entries. So it's going to be minus 1 times 0, which is 0, minus 2 times 2, which is minus 4. Let's move on to the next column. So it's 0, 3, and it will be matched up with the first row. So you're going to get 4 times 0, which is 0, plus 1 times 3, which is 3. And then you're going to move on to the second row. Okay, so 0 gets multiplied by 0, which is 0, and then minus 2 times 3, which is minus 6. Okay, so what is the answer? Well, minus 2, minus 4, 3, and minus 6. Okay, so this is a very good example to notice that these two answers are not the same. I have multiplied matrices AB and BA. They are not commutative. Okay, so you're not going to necessarily get the same answer for when multiplying A by B or B by A. So multiplication is not commutative. You can have certain matrices when that happens, okay, so it won't matter which way around you multiply, but in general it's not commutative. Okay, so let's move on to example 7. We've got 8 as well. Okay, so we've got two matrices. We are told that B multiplied by A gives you a 0 matrix, which is a 1 by 1 matrix. And we're going to find AB in terms of A. Okay, so what they are saying is that when you multiply B by A, i.e. minus 1 times A multiplied by, let me just write it higher, B times 2. Okay, so remember over here you're going to have example 7 actually. AB will need to find AB, yeah. But we are told that BA is equal to 0. So let's hopefully can squeeze it here. So let's find what BA is. It's a 0 matrix, so with 1 by 1 matrix with just one entry equal to 0. So that also tells me that when I multiply B by A, I should be getting a 1 by 1 matrix. There you go. And clearly over here, you've got straight away that this column needs to be matched up with this row. So you're only getting one answer. You're going to get B times minus 1, which is minus B, and then 2 times A, which is 2A. But we are also told that this is equal to 0. Minus B plus 2A is equal to a 0 matrix. So minus B plus 2A is equal to 0. Okay, which gives me B is equal to 2A. Might be useful for the next step. Now, they ask me to find out what AB is, but in terms of A only. So we're going to do that multiplication. So the first, remember, each column of the second matrix matches up with the first row, each row, first row and the second row. So the top left entry, you're just going to get one multiplication. So it's minus 1 times B, so it's minus B. Then you're going to match your B with A, which is in the bottom, and you're going to get AB. Then you're going to get 2, going to select that minus 1, so that second column goes to multiplied with the first row, so it's minus 2. And lastly, you're going to get 2 times A. It's 2A. Well, that's a nice answer, but it's not just in terms of A. So now we're using the result that we found earlier. B is equal to 2A, and then replace each B in here with 2A. So you're going to get minus 2A, minus 2, 2A times A, you're going to get 2A squared, and then 2A is already, doesn't need to be replaced. There you go. Okay, so last example before exercise 6b, we are told to multiply B by C by A. Okay, in terms of multiplication, it has to be done in that order. So you can't suddenly do CB, because it's not commutative. But you can, is associative. Don't need to know all those words, but you might be remembered from lower down the school. Which means that you can carry out multiplication either by doing B by C first and then multiplying that result by A, or doing, if you prefer, C by A first and then putting B at the front of that result and multiplying it together. Well, I'm going to do B times C first. So B times C, so it's 3 minus 2. Let's multiply it by 4 and 5. Okay, so this is going to be 1 row and 1 column in the second. So that whole column selects 1 row. There will be just 1 entry. So you're going to get 3 times 4. And then minus 2 times 5. That's 1 by 1 matrix. This is going to be 12 minus 10, which is 2. Okay, and then we need to do 2 times A. There you go. So this is going to be like this. 2 is going to be matched up with the first column, the second column, and the third column. So it is like really like multiplying by scalar in this instance. 2 minus 2 and 4. Should really be written as a matrix. There you go. So that's the answer. Okay, if you want to check whether you get the same result by doing CA first, just for practice. So if I do 4, 5, and then multiply it by 1 minus 1, 2. So my first column here is going to be matched up with the first row. So I'll just do it in colors. So remember that column with that row. So you're going to get 4. Then you're going to go this first column with the second row. So that's 5. You're going to get minus 4, minus 5, 8, and 10. Okay, so this was the result of matching one column, let's say, with this row. This is one first column with the second row, so I'll call it B. This is second, so second column with the first row, second column with the second row, and then third column. You might want to look at this labeling first. And then we're going to do B times CA. So B times CA, because that's the order I said we'll try. So if I do 3 minus 2, we're going to multiply that by 4, 5, minus 4, minus 5, 8, 10. We should be getting the same result. Let's just have a look. So this is going to be just one column, row, let's call it A, and 3 columns. So this one matches with that. What do I get? Well, I get 4 times 3, which is 12, minus 2 times 5, which is 10, so it's 2. The next one is going to be minus 12, add 10, which is minus 2. And then you go 3 times 8, which is 24, minus 20, so it's 24 minus 20, which is 4. There you go. Both the same. So you can have a go at exercise 6B now.